Alright, Chem students, today we're going to start our unit on the periodic table. You need your periodic table notes, a periodic table, and something to write with. The first periodic table was created by Dmitri Mendeleev, and for that reason we call him the father of the periodic table. Now, Mendeleev was a Russian chemistry professor. In writing a textbook of general chemistry, he compiled vast quantities of data on the elements. He realized as he examined all that data that there were certain chemical properties of the elements that repeated themselves when the elements were placed in order of atomic mass. Based on his realization, Mendeleev arranged the elements in order of increasing atomic mass, and in such a way that elements with similar chemical properties fell in the same column. He published a primitive version of today's periodic table in 1869. It contained the 62 elements that had been discovered at that time. Now, the genius of Mendeleev's work was that he left spaces in his table for elements that had not yet been discovered. Because of the patterns and chemical properties that he had discovered, he predicted that some still unknown elements must exist to fit in those holes. And good examples of this were scandium, gallium, and germanium. Now, Mendeleev's system did contain one inconsistency. He placed the elements in order of atomic mass to create his table, but he was forced to break the order a few times to preserve the patterns he had discovered. Something was not quite right, but it would take further scientific discovery to shed light on the problem. Alright, the next person to contribute to our periodic table was Henry Moseley. So shortly after Rutherford's discovery of the proton in 1911, Moseley performed experiments with X-rays to determine the number of protons in various elements. When Moseley arranged the elements of Mendeleev's periodic table according to increasing atomic number instead of atomic mass, the inconsistencies associated with Mendeleev's table were eliminated. Now, the modern periodic table is based on Moseley's arrangement by atomic number. Now, sadly, Moseley was killed in action during World War I. All young men at that time were given a rifle and shipped off to the front lines, and he was killed in action. And because they realized it, Britain adopted the policy of exempting top scientists from fighting in wars, and a lot of other nations followed suit. They could be much more benefits staying at home working on research. From Mendeleev's and Moseley's work comes the periodic law, which explains that properties of the elements are periodic functions of their atomic numbers. What this means is that if we arrange the elements in order of increasing atomic number, we will repeatedly encounter elements that have similar chemical and physical properties. These elements appear in the same vertical column or group. Now, our last scientist to contribute to our periodic table was Glenn Seaborg. He was an American chemist whose involvement in the discovery of 10 transuranium elements earned him a share of the 1951 Nobel Prize in Chemistry. Now, this is relatively new. We have some new elements that were just added to our periodic table. In 2012, the International Union of Pure and Applied Chemistry, also known as IUPAC, approved the names flerovium and livermorium for elements 114 and 116. Both elements are man-made and were first synthesized at the Joint Institute of Nuclear Research in Dubna, Russia in 1998 and 2000. The elements were created by fusing together calcium-48 and curium-248. This resulted in the creation of the new element 116, which was called livermorium. This element then decayed into flerovium with 114 protons, almost immediately. The names were chosen to honor the labs in which they were created. Okay, that's it for today's lesson. We'll see you on the next video.